Hi, Assalamualaikum everyone. Welcome back to Teacher Nina's class for Year 4 Science Process Skill. So for today's lesson, we are going to part 3, which is defining operationally. Now let's look back at the 12 science process skills that you need to know. So today we are going to learn the 9th science process skill, which is defining operationally. So what is defining operationally? It is actually a skill to define a concept by stating what can be carried out and observed. Okay? So to sum it up, it is actually a science concept that we must mention with the parameter that can be defined operationally by how we can measure it quantitatively. Okay? Alright, don't worry, let's look one by one. Okay? So what is parameter? Parameter is a characteristic of an object that can help define or classify that object. Okay, we have two types of parameter. The first one is qualitative. Qualitative is the kind of parameter that we can observe using our 5 senses. You remember? Sense of sight, hearing, smell, sense of touch, and taste. So these parameters do not involve any numbers. Okay, for example, the color, taste, texture, smell, and also appearance. Next one is quantitative. So quantitative are the numerical data that we gather from an object. For example, the length of an object. Okay, you can see it uses number. Okay, the number of, the weight, height, distance, and also temperature. All of these are numerical data. That is why we call it quantitative. Okay, quantity. Now, let's look at some examples so you can understand more about parameter. Okay, let's look at the first one. As simple as a cup of coffee. So what are some of the qualitative parameter that we can say about a cup of coffee? The characteristics of a cup of coffee that we cannot measure using numbers. Okay, for example, the taste. The taste of a coffee is bitter. Do you see any numbers involved there? No, right? So that is the qualitative parameter. And the color is black. There's no need number to it. But what about quantitative? What numbers can you put to coffee? I'll give you an example so you can see. Temperature. The temperature for this cup of coffee is, for example, 70 degrees Celsius. So you can see the number 70. So that is quantitative parameter for the cup of coffee. And another example is the volume of coffee in that particular cup is, for example, 40 milliliters. Okay, so now you get it? Okay, now let's look at another example. What is that? Yep, it's an aeroplane. So the qualitative parameter that we can observe using our senses, for example, the material that it is made, it is using metal. So no numbers there, right? And also the color. For example, this picture, it shows a black aeroplane. Okay, so these are the qualitative examples, the qualitative characteristic of this airplane. So what about the quantitative characteristic? The parameter. Weight. Yes, do you know that an average weight of an aeroplane is 41,000 kilograms? and also the length. Okay, the length of this aeroplane, for example, is 50 meters. So you can see when we attach numbers to an object, it is definitely quantitative characteristics. Okay, so to define something operationally, okay, getting back to our topic today, your idea actually must be a concept, not just a simple object with quantitative parameter. What I'm trying to say here is, when we are trying to define something operationally, for example, the two examples that we talked about earlier, it must not be like that. Like, we are not going to say, okay, the definition, the operational definition of the temperature of a cup of coffee is, no, we are not going to say that. We are going to mention the science concept. It is not just a simple object like a cup of coffee and its temperature or the weight of an aeroplane. It must be a concept, a science concept. Okay? Now, let's try. If you are a bit vague about this, don't worry. I'm going to go through one by one with you. Okay? Let's try the first example. Yes, a magnet. So, the object is a magnet. But what science concept can we say about magnet? Yes, the strength. Okay, the parameter we are using now is the strength of a magnet. So when you as a scientist, you are trying to make people want to understand how are you going to measure the strength of a magnet. So you need to find out what is the correct measurement that we can use to define the strength of a magnet. Okay, one example that we can think of is how much thumbtacks it can attract. Okay, so to put it in a nice sentence, it's like this. The operational definition of the strength of a magnet is the number of thumbtacks it can attract. So now do you see that? Okay, when you are trying to convey a science concept, you are trying to make people understand how you are going to measure it to show that this is the strength of a magnet. You need to put on the measurements that align with that concept. So that is what defining operationally means. Okay, so let's look at the second example to make you understand deeper. A straw tower. Okay, a tower made of straws. So when we think about straw towers, of course, the science concept that we can relate to is the stability, right? So when we are saying about the stability of a straw tower, how are we going to measure it? Okay, one way is how large its base surface area is. So that is how we say how stable a straw tower is based on how large is the area of its surface base. Okay, so to put it nicely in a sentence, it should look like this. The operational definition of the stability of a straw tower is the size of the surface area of its base. Okay, just put it nicely like that. Okay, now on to the third example. A car, a simple object, car. But the science concept to it is, maybe one of it is the speed of car. Okay, so how can you define what is actually the speed of car? How can you measure the speed of car? One example is how much time it takes for it to reach a certain distance. For example, you have set a certain distance from, let's say, point A to point B. So the speed of the car is how fast that car can reach to point B. That is the operational definition of the speed of car. So to put it in a nice sentence, it should look like this. The operational definition of the speed of a car is the time it takes to reach a distance. Okay, are we clear now? Alright, now it's time for this week's assignment. So to go through this assignment, you need to go on through this steps. Okay, there's working steps for you to know how to go about it. Okay, the first step is you need to identify the concepts. Okay, identify the concepts, and then you determine the measurements, and then write the full sentence. Okay, this is this week's assignment. Okay, I need you to write it in your book, or you can do it digitally using Word or Google Sheet. So first, you need to match the concept. The concept is in the cyan boxes. I've written it all, science concept, but the corresponding measurements are not in the correct order. So I need you to match it up. Match the concept with the corresponding measurement. Okay? And then you need to write the full sentence. Okay. Don't worry, I'm going to show you an example. The first one, I have done it for you. So the first one is the rate of evaporation. The corresponding measurement is the time taken for a towel to dry completely. So to write it out, it should look like this. The operational definition of, and then you copy, the rate of evaporation is, and then you copy the measurement, the time taken for a towel to dry completely. Full stop. That easy. So you think you can do number 2, 3, and 4? Yes, I'm sure you can, because you're awesome. Okay, that's all for this week. See you next week. Bye. Assalamualaikum.